Hello everyone, welcome to IGCSE with Optimus. Subscribe to our channel and hit the bell icon to never miss an update on our IGCSE content.
Hello dear students. So today we are going to solve physics paper 41 from May-June series 2024. You can see on the screen the question number 1 for the paper says that a long tube contains oil. A small ball is held at rest at the surface of the oil. At time t equal to 0, the ball is released and it begins to fall vertically through the oil. Now we can understand that as the ball is falling through the oil is going to apply force on the ball in upward direction. We call that force as drag force or resistive force from the oil. We will just mark that arrow pointing upward for the force applied by oil on the ball. Figure 1.1 shows the ball falling through the oil. As the ball begins to fall through the oil, it accelerates. The first question says define acceleration. We can say acceleration is rate of change of velocity. Question number B, the mass of the ball is 0.0075 kg. Calculate the resultant force acting on the ball when it is accelerating downward at 2.8 meter per second square. So we are given with mass, we are given with acceleration, and they are asking us to find out force. The formula for force will be mass into acceleration. So F will be equal to mass multiplied by acceleration, that is 0.0075 multiplied by 2.8. The answer is 0.021 Newton. Question C. As the ball falls, its speed v is recorded. Figure 1.2 is the speed time graph for the falling ball. Now we know that when we talk about speed time graph, the gradient of the speed time graph gives us acceleration. Looking at the graph, you can understand that the graph shows overall decreasing gradient, meaning the acceleration of the ball is decreasing. Now why the acceleration would decrease? It's because the ball's weight is acting downward and the resistive force, we call it as drag force, on the ball from the oil is acting in upward direction. The net force would decrease, and because of that, the acceleration of the ball will also decrease. Eventually, the ball is going to reach to constant velocity. We call that constant velocity as terminal velocity. Question says that describe what happens to the acceleration between 0 seconds to 0.04 seconds. So as we discussed, during the motion of the ball in the oil, the resistive forces are acting on the ball, and because of that, the acceleration decreases. So in the pointers, we can write ball experiences drag force in upward direction, because of which the net force on the ball decreases, the acceleration decreases. Eventually, ball achieves terminal velocity. Next question, by drawing a tangent on figure 1.2, determine a value for the acceleration of the ball at time 0.01 second. Now if you see the graph in 0.01 second, the graph is a curve, and when we have to calculate the gradient for the curve, we have to draw a tangent on the graph. So what we will do, we will draw a tangent on this graph, something like this. And we will try to find out the acceleration of the ball at 0.01 second. Note that the length of the tangent is not going to change your answer. So if a student draws a longer length for the tangent, then also his answer is going to be same. Reason being, for a straight line, the gradient remains constant. So we can take the coordinates for this point, these points, and we can calculate the gradient. The x coordinate for the first point will be 0.03. I'm sorry, y coordinate for the first point will be 0.03 and the x coordinate will be 0.005. For the second point, the x coordinate will be 0.02 and the y coordinate will be 0.05. So we can use these pointers and calculate the gradient for the graph, and that will give us acceleration. So acceleration is equal to gradient, that is equal to y2 minus y1 upon x2 minus x1. Now y2 is 0.05 and y1 is 0.03 divided by x2 minus x1, that is 0.02 minus 0.005. So if we do this on calci, the answer is 1.33. So we can write it as 1.3 meter per second square. That will be the acceleration for the ball. We'll go to the second question now. In the second question, they have said figure 2.1 shows two identical trolleys P and Q. Both the trolleys are held at rest on a frictionless surface. A load is fixed to the trolley P. There is a compressed spring between trolley P and Q. The trolleys are released. As the spring expands, it pushes the trolleys apart. Trolley Q moves to the right at constant speed of 0.36 meter per second. So the trolley's movement after the spring expands is on the right hand side and the value for the speed is 0.36 meter per second. The mass of each trolley is 1.2 kg and mass of the load on trolley P is 1.5 kg. So you can understand that trolley P is having load on it. The value of the load is 1.5. So total weight over here is going to be, total mass over here is going to be 2.7 kg. And for trolley Q, the mass is going to be 1.2 kg, that is its own mass. The spring has negligible mass. Calculate the speed at which trolley P moves to the left. Now what we have to understand over here is we are going to use formula for conservation of momentum. That is, total momentum before collision is equal to total momentum after collision. As you can see in the diagram, initially both the trolleys are held by spring together, meaning their initial momentum is going to be 0. After the spring expands, one trolley, that is Q, is moving towards right and trolley P is moving towards left. So their velocities are opposite to each other, and because of that, one will be marked as positive and another will be marked as negative. So we can simply use formula, that is mass of trolley P plus the mass of load attached to trolley P plus mass of trolley Q, and all will be multiplied by 0 because they are not moving initially. After the spring expands, mass of trolley P attached with load on it is moving with, let's say, velocity v, and the trolley Q is moving with velocity v, which is given to us 0.36 meter per second, but we will mark this velocity as negative. Why? Because it is moving opposite. So we can understand that since the trolleys are not moving initially, this entire term is going to be 0. And we can rearrange the formula now and we can write mass of trolley P plus load on it moving with velocity v after the collision will be equal to mass of trolley Q into velocity of trolley Q. So this mass of P plus mass of load on P is total 2.7 kg into V is equal to mass of trolley Q is 1.2 and its velocity after collision is 0.36. So V can be worked out as 1.2 into 0.36 divided by 2.7. So if we do this on calci, it will be 1.2 into 0.36 divided by 2.7. The answer will be 0.16 meter per second. So the speed of P after the spring expands is 0.16 meter per second. The next question says kinetic energy of the trolley Q when it moves at speed 0.36 meter per second square. Simple formula for kinetic energy, Ke is equal to half mv square. So half into the mass of trolley is 1.2 and the speed is 0.36 the whole square. The answer for this is 0.0777 is the Kelsey display answer, but we will be writing answer in 3SF. So our answer will be 0.078 joule. The next question is state the energy transfer that take place as the spring expands. So when the spring is initially compressed, we know that the spring is going to have elastic potential energy. And as the spring will expand, its elastic potential energy will decrease and the same elastic potential energy is given to the trolleys in form of kinetic energy. So the main energy transfer here is elastic potential energy of spring is converted into kinetic energy of trolleys. We will go to the third question now. Question number 3, figure 3.1 shows a small block of ice floating in a beaker of warm water. State one way in which the motion of the particles in ice differs from the motion of the particles in water. So we know that here we are talking about two different states of matter. Ice is a solid state material and water is in liquid. Talking about the motion of the particles, we can simply write in ice, particles vibrate to their mean position, whereas in water the particles slide over each other. Next question, question B, energy is transferred from the water to the block of ice. State the name of the thermal process that transfers energy from the water to the ice. You can see in the diagram that water and the ice particles are in contact with each other. Remember that out of three processes of thermal conduction, that is, thermal energy transfer, that is conduction, convection and radiation. Conduction takes place when two particles are in contact with each other, irrespective of their state. So here, since water and ice are in contact with each other, the energy transfer between them is going to be by process conduction. Next question. Initially, there is 0.34 kg of water in the beaker. The specific heat capacity of water is 4200 joules per kg degree Celsius. Calculate the energy transferred from the water as its temperature decreases from 28 degrees to 10 degrees. So you can understand here that 28 degrees to 10 degrees, it is the difference of 18 degrees of temperature. Now, how do we calculate energy when the data is given mass, specific heat capacity and the temperature difference? We have the formula that energy transfer is equal to mass multiplied by specific heat capacity multiplied by change in temperature. Here, the mass is 0.34 kg, the specific heat capacity is 4200 and the difference in temperature is 18 degrees Celsius. If we do this on Calci, the answer we get is 25,704, but we will be writing answer in 2SF or 3SF, that is two significant figures or three significant figures. The answer will be 26,000 joules. Next question, the temperature of the water near the ice decreases first. Explain how convection causes the temperature of the of all the water in the beaker to decrease. We will go back to the diagram. You can see that as the water over here near the ice is cooling down, what will happen if the temperature decreases? We know that temperature is inversely proportional to the density of the particles. If water loses its energy to the ice, the density of the water is going to increase, and these heavy particles of the water will settle down and they will be replaced by the lighter particles at the bottom. This sets up the convection currents in the water, and because of that the entire water cools down. So they are asking us to explain how convection causes the temperature of all the water in the beaker to decrease. So we can write that water near the ice cools down and its density increases. These heavy water particles sink to the bottom and the lighter particles move upward. So this cycle keeps on going on, and because of that the entire water cools down. We'll go to the next question. State what happens to the internal energy of the water as the temperature of the water decreases. Describe the change in terms of energy of the particles. Now first thing we need to know, what is internal energy? The internal energy is the sum of potential energy and the kinetic energy of the particles. As we saw, water is losing its heat energy to the ice, so the water is going to cool down, and as it cools down the internal energy of the water will also decrease. So we can write that water particles lose their energy and their kinetic energy decreases. Hence, their internal energy also decreases. We will move to the next question now, that is question number 4. The question is about chapter light and the lenses. Question says the lens is a magnifying glass. The lens in a magnifying glass is a converging lens. We know that converging lens can be used as magnifying glass. Figure 4.1 shows the lens of magnifying glass, its two focal points f1, f2 and its principal axis. The first question they are asking is state what is meant by the focal point. Now what do we understand by focal point? It is the point on the principal axis on which the rays converge after they pass through the lens. So we can write that the point on principal axis at which rays passing parallel to the axis converge. Now what do we understand by converge? They meet each other after passing through the lens. So for example, we draw a ray parallel to principal axis like this. After passing through the lens, this ray is going to go through point F2, okay, like this. So if it goes through the point F2, we can say point F2 is the focus, and the distance between the optical center and the focus is called as focal length of the lens. We'll go to the next question. They are asking a student using the magnifying glass sees magnified image of an object. On figure 4.1, mark a point X on principal axis for the possible position of the object and point E for possible position of student's eye. Now we need to understand when the magnifying convex lens used as magnifying glass. Whenever we keep the object between optical center and the focus of the convex lens, the image of the object is formed behind the object on the same side of the lens, and that is when the convex lens is used as or works as magnifying glass. So to have a magnified image of the object, we have to keep the object between optical center and focus, either on this side, left side, or we can keep it on the right side as well. So let us say that we are keeping the object between optical center and focus over here. We have to mark this point as X as they have suggested in question. And the next is the point E for the possible position of the student's eye. If the object is kept over here, the image is going to be somewhere here. And to see this image, we have to have our eyes positioned somewhere over here. So note that the object and the image, they are on the same side of the lens, and so your eyes should be on the other side of the lens to be able to see this magnified image. Going to the next question, they are asking underline two words in the list that describes the image produced in A2. So we can see it is going to be an magnified image, okay, but it is on the same side as that of object. When the image and the object are on the same side of the lens, we call that image as virtual image. So the first point that I will mark here is they are asking us to underline. So the image is going to be virtual and the image is going to be upright as shown above. The refractive index of the glass used to make the lens is 1.5. The speed of the light in air is 3 into 10 raised to 8 meter per second. They are asking us to calculate the speed of the light in the glass. Now we have one formula for refractive index which links the speeds of the light in two different media, that is n equals to v1 upon v2, where v1 is the speed of light in vacuum, which they have already given us 3 into 10 raised to 8 meter per second. So if I have to find out the value for v2, it will be v1 divided by n, that is 3 into 10 raised to 8 divided by 1.5. The answer would be 2 into 10 raised to 8 meter per second. The next question is, state what happens to the wavelength of the light as it passes into the lens. Now what will happen to the light if it passes through the lens? Now lens is a solid material and the light is coming from air. In solids, the speed of light decreases. What is the relation between speed of light and the wavelength? We know the formula, V is equal to F lambda. So velocity of the light and the wavelength, they are directly proportional. If the velocity of the light is going to decrease in the glass, the wavelength of the light will also decrease in the glass. So we can write first point that in glass, velocity of light, or you can say speed of light, decreases since velocity and wavelength are directly proportional. Wavelength also decreases. Next question, converging lenses are used in spectacles to correct one problem with the vision. State the name of the problem and explain how a converging lens is used to correct this problem. Now, which problem is corrected by the convex lens? We will first draw the diagram for that and then we will write the explanation. Consider this is your eye and here we are having retina. So this is your retina. So ideally for a healthy human eye, the image of the objects should be formed on the retina. But in this issue, what happens is the the rays coming from nearby objects, they meet each other, but they meet outside the retina. Now, since they meet outside the retina, the image is not clear or the object is not clearly visible to the person. We call this problem as hypermetropia. We can also call it as long-sightedness. wherein the person is able to see the objects which are far from the eye, but the person is not able to see the objects which are near to his eye. Now, how this problem can be resolved? Again, we will draw the diagram. So, understand the problem first. The image is forming behind the retina, meaning the rays are meeting later than the expected point. Okay, so we have to converge them, we have to make them meet earlier than where they are meeting right now, and to do that we make use of convex lens. So suppose this is your eye again, and we are using a convex lens like this. Now what will happen? The rays coming from the nearby objects they will converge firstly due to the lens, and secondly they'll again converge to meet at the retina like this, and the person will be able to see the objects clearly. So what we can write in the problem statement? We can see that the rays coming from nearby objects are meeting behind the retina. Using convex lens, makes these rays converge earlier and on the retina. So since now the rays are meeting on the retina, we will be able to see the objects clearly. The person having this defect will be able to see the objects clearly. We'll go to the next question, question number 5. It says, describe how longitudinal waves differ from the transverse wave. So we know about transverse wave and longitudinal wave. In longitudinal waves, the vibrations of the particles are parallel to the direction of the wave. We can also say the vibrations are to and fro. Whereas in transverse waves, the vibrations of the particles are perpendicular to the direction of the direction of the wave, and they are up and down. So for longitudinal wave, we can say particles of the medium vibrate to and fro, we can say parallel to the wave. Whereas in transverse wave, the vibrations are perpendicular to the wave. Okay. Going to the next question, it says figure 5.1 represents a seismic wave produced by an earthquake. State whether this seismic wave is a P wave or S wave. P stands for primary and S stands for secondary. Now note that seismic waves, the P waves in seismic waves are primary and they are longitudinal waves, whereas S waves in seismic waves are secondary waves. They are transverse in nature. The wave that they have shown is actually a longitudinal wave because you can see the vibrations are parallel. And so the wave that we are seeing is a P wave, and we can write the reason. The vibrations are parallel to wave and they are longitudinal in nature. Next question, the wave represented in figure 5.1 has a wavelength of 1.2 into 10 raised to 4 meter. Calculate the actual distance between point J and point K. We'll try to understand from the diagram. Point J is indicating a compression, you can say. The next compression we can see is somewhere here. So from here to here on the diagram is one wavelength. Okay. the distance between one compression to the next rarefaction, which is represented by point K over here, is actually half of wavelength. So the total distance between point J and K is 1 plus half wavelength. So we can say it is 1.5 times of the wavelength. We can write the total distance is going to be 1.5 times of the total wavelength, that is 1.5 multiplied by 1.2 into 10 raised to 4, and the answer would be 1.8 into 10 raised to 4 meter. The next question, the wave in 2 travels through the ground at speed 4600 meter per second. That is the speed of the wave. As the wave passes a certain point, the ground completes 5 oscillations. Calculate the time that it takes for the wave to pass. Show your working. So we will try to understand from the data that what all information is given to us and what are they trying to ask. They have given us the velocity of the wave. In the question previous to this, we have got wavelength of the wave. So we have wavelength with us, we have velocity with us. From this, we can calculate the frequency of the wave. Now the frequency will give me the number of oscillations happening in 1 second. And since I am given with calculations for, they are asking us to find out something for 5 oscillations, we will try to multiply the frequency with number of oscillations, okay, total number of oscillations. So the first thing that we will do is we will find out the frequency using formula V is equal to F lambda. So F is equal to V upon lambda. V is 4600 divided by the wavelength that is given above, 1.2 into 10 raised to 4 meter. Now this answer is 0.383 hertz. Now this is the frequency of the wave, okay. Now based on this frequency, I can calculate the time period of the wave. So time period is going to be 1 upon frequency, that is 1 divided by 0.383, and the answer here is 2.61 seconds. So this gives me the time taken to travel for one wave, and one wave means one oscillation. The question is asking us to find out the total time for 5 oscillations. So what we have to do? We have to simply multiply. Total time will be equal to time for one wave, that is 2.61, multiplied by the number of waves, 5 waves. So 2.61 multiplied by 5, we are going to get answer 13 seconds. Question number 6. Figure 6.1 shows an isolated metal sphere suspended by an insulating thread from the ceiling. The sphere is negatively charged, meaning there will be negative charges spaced on the sphere, something like this. The charge on the sphere produces an electric field in the surrounding. State what is meant by electric field. Now what do we understand by electric field? It is the region in which any electric charge experiences force. So whenever we keep any electric charge in any space, it is going to have a region around it in which it might apply attractive force on the other charges or repulsive force on the other charges. This region in which the charge experiences force is called as electric field. So we can write the region in which electric charge experiences force. Okay. Next question. Draw on figure 6.1 to show the pattern and the direction of the electric field produced by the charge on the sphere. Draw at least 4 lines. As we know, this sphere is negatively charged. When we draw the electric field lines, they are always pointed from positive to negative. Since the sphere is negative, the field lines are going to be pointing towards the sphere. They have said to draw at least 4 lines. So we can draw lines like this and make sure that these lines are touching the sphere and their arrows are pointing towards the sphere like this. Question B, the magnitude of the charge on the sphere is 3.5 into 10 raised to minus 10 coulomb. Magnitude means value. So they are telling us the value of the charge. What is the value? 3.5 into 10 raised to minus 10 coulomb. Charge is measured in coulomb. An earthed wire, metal wire is touched against the surface of the sphere and the sphere is discharged. State what happens in the wire as the sphere is discharged. Okay. So I'll just show it on the diagram. Suppose we connect an earthing wire like this to the sphere. We know that Earth acts as a reservoir of charges, meaning Earth can take in a lot of charges from the charged objects, and Earth can also give out its own charges to the objects if required. Here, the sphere is having excess negative charge. When we connect it with the Earth, these excess charges are going to go in the ground through this metal wire, because metal wire is going to be a conductor. They are asking us to state what happens in the wire as the sphere is discharged. We can say the negative charges in sphere move through the metal wire into the ground, and whatever excess charge was there is decreased. Okay, so as the excess charge is decreased, again we can say the sphere is going to be neutral. The next thing they have said is it takes time 0.14 nanoseconds. Please note that the small n over here is nano. So 0.14 nanoseconds for the sphere to discharge completely. Calculate the average current in the earthed wire as the sphere discharges. So we are given with time, we are given with charge, we have to find out the current. Formula for current will be equal to charge divided by time. The value for charge is 3.5 into 10 raised to minus 10 and divided by time. Please note that it is 0.14 nanoseconds. The power of 10 for nano is 10 raised to minus 9. So we will have to write 0.14 into 10 raised to minus 9. If we do this on calci, it is going to be 2.5. So what is the value of current? It is 2.5 ampere. We'll go to the next question now. Question number 7. It says the electromotive force of the battery is 7.5 volt. Define the term electromotive force. So what do we understand by electromotive force? Suppose we are talking about a basic circuit like this. This is a conducting wire, and we have to move a unit charge from the wire from this end of the wire to the other end of the wire. To move the charge throughout the circuit, some energy is required, and that energy is provided by battery. So the amount of work done, or you can say the energy supplied by battery to move unit charge throughout the circuit, is called as electromotive force. So how will we define electromotive force? It is work done to move unit charge through the circuit. Note that the formula for EMF is W divided by Q, that is work done per unit charge. Next question, the battery is connected in series with variable resistor and a 30 ohm resistor. So there are two resistors, one is variable whose value of resistance can be adjusted, and another is a fixed resistor of 30 ohms. The battery is made using 1.5 volt cells. Draw a circuit diagram that shows all 1.5 volt cells connected to produce an EMF of 7.5 volt. The variable resistors and 30 ohm resistor in the circuit. Now, to find out the number of cells required to have total 7.5 volt of EMF, we have to simply divide it by 1.5, that is the value of EMF or potential difference in one cell. the total number of cells we will need is 5. So we will show these 5 cells like this. So these 5 cells in total are going to produce the EMF of 7.5 because each cell is having EMF of 1.5. 1.5 multiplied by 5 will be 7.5. We have to connect it to a variable resistor. This is the symbol for variable resistor with an arrow, and we have to connect it with another fixed resistor whose value is 30 ohms. This is going to be the circuit. The next question they are asking is the resistance of the variable resistor can be varied from 0 ohms to the maximum resistance of 150 ohms. Using the axis in figure 7.1, draw graph to show how the current in the circuit varies with the resistance of the variable resistor as it increases from 0 to 150. Determine and label the value of the maximum current on the y-axis. So, if the variable resistor is increasing its value to 150 ohms, then the total resistance in the circuit is going to be 180. Okay, but if the variable resistor is having value 0, then only 30 ohm resistor is going to be the part of circuit, and then the value of resistance in the circuit is going to be 30 ohm. So when we will have the highest value of current in the circuit, when we will have highest value of current in circuit when the resistance is lowest. Why? Because we know that current and resistance, they are inversely proportional. So what will be the least value of resistance in the circuit? When variable resistor has 0 resistance and the external resistance of 30 ohms is connected or the part of the circuit. So the maximum value of current will be equal to V divided by R, that is 7.5 upon 30. The answer is 0.25 ampere. Now as we know, they are asking us to first mark on the graph this maximum value of current. So we will mark it over here as 0.25 ampere. Now when we have 75 ohms of resistance, we need to understand that the current is going to decrease as the value of resistance is going to increase. Okay, so we have to show the graph like this with the decreasing gradient. Okay, as the value of resistance is going to be increasing, the current in the circuit is going to be decreasing. We will go to the next question, that is question number 8. The question says the isotope of thallium-208 is radioactive. It decays by beta decay. Thallium-208 decays to an isotope of lead. Complete the equation for this decay. So we know that whenever there is a beta decay, the original nucleus, we call it as parent nucleus, the proton number of the parent nucleus increases by 1. So currently the proton number for thallium is 81. The proton number for lead is going to be 82. Whenever there is beta decay, there is no change in the mass number. So the mass remains unchanged, that is 208. For beta, the mass is 0 and the charge on beta particle is -1. Whenever we are writing such equations, we have to understand that the top number, that is mass number, should balance on either sides of the equation, and the proton number should also balance on the either sides of equation. Here 208 plus 0 on the right hand side balances with 208 on the left hand side, and 82 minus 1 on the right hand side balances with 81 on the left hand side. The next question is the beta emission of thallium is accompanied by gamma emission from the nucleus. Explain why this gamma emission does not affect the numbers in the equation in A1. So what we know about gamma radiations? Gamma radiations are just the energy transfer, so you can say release of energy. With gamma radiations, there are no protons or neutrons leaving the nucleus, and that is why whenever gamma radiations are emitted by radioactive sample, we don't see any change in the proton number or mass number. So we can write gamma radiations are chargeless as well as massless. Since they are chargeless and they are massless, there won't be any effect seen if the gamma radiations are emitted. The next question is, suggest one reason why a nucleus of thallium-208 is unstable. Now here we need to understand why any radioactive sample is radioactive actually. It is because of excess energy that the nucleus carries. Now why it has excess energy? It is because the difference between the protons and neutron number. If the protons and neutron numbers are less and their total is less, the nucleus is moreover stable. But if there is large difference between number of protons and neutrons, because of that the nucleus becomes unstable and that it also becomes radioactive. So here we can write there is difference between number of neutrons and protons and this makes the nucleus heavy and unstable. We'll go to the next question. It says a sample of thallium is placed in a thick lead container. Figure 8.1 shows a narrow beam of beta particles and gamma radiations emerging from the small hole in one side of the container. The narrow beam enters in a region where there is a magnetic field and the direction of the magnetic field is into the page. On figure 8.1, draw a line labeled beta to indicate the path of beta particles in the magnetic field and line labeled gamma to indicate the path of gamma radiations in the magnetic field. Now note that gamma radiations are chargeless as well as massless, because of which gamma radiations are not going to change their path even if they are passing through the magnetic field. So the first thing that we will draw is the line for gamma, and that line for gamma is going to be straight line without changing its path. We will label this line as gamma radiation. For finding out the path for beta, we have to use Fleming's left hand rule. Now, according to Fleming's left hand rule, if the magnetic field is into the page and the beta particles are going towards right side, the direction of the current is going to be left hand side. So if you use Fleming's left hand rule, you will be able to work out the direction of the beta particles is going to be towards the bottom of the page like this. While using your left hand for finding the direction of beta, please note that your index finger should be in the direction of the magnetic field, which is going to be into the page. The direction of current is going to be opposite to that of beta particle, so it's going to be towards your left hand side. And then if you stretch your thumb, it will point towards you, or you can say towards the bottom of the page, and so the direction of the beta particles is towards the bottom of the page. We will go to the next question. The sun is one of many billions of stars in the Milky Way. The sun emits very large quantity of energy as electromagnetic radiations. State the three regions of the electromagnetic spectrum in which the sun emits most energy. So as we know, sun emits energy in three parts of electromagnetic spectrum, that is infrared, visible light and UV rays. So our answer will be infrared radiations, visible light and ultraviolet rays. Question B says that electromagnetic radiation from sun travels at speed 3 into 10 raised to 8 meter per second. The radiation takes 500 seconds to reach the earth. Calculate the distance from sun to the earth. We are given with speed, we are given with time. We have to find out the distance. Simple formula, distance is equal to speed into time. The speed is 3 into 10 raised to 8 meter per second and the time taken is 500. So the answer is 1.5 into 10 raised to 11 meters. Question C. Approximately 4.6 billion years ago, the sun formed from an interstellar cloud of gas and it became a stable star. Describe and explain what happens as an interstellar cloud of gas forms a protostar. So when the protostar forms, first of all, we need to understand how the sun forms or how any stable star is formed. The nebula particles, which are the gaseous and dust particles in the space, they start coming towards each other due to the gravitational pull, and because of that they lose energy. As they lose energy, they come closer, they form a clump of matter, and as they are losing more and more heat energy, that clump of matter, it goes into a nuclear fusion reaction, and that nuclear fusion reaction leads to formation of the star. So for this question they are asking, describe and explain what happens to as an interstellar cloud of the gas forms a protostar. So we can write in the answer the first point as gas particles lose their kinetic energy and they move closer. They collapse into each other to form a clump of mass, and this collapse that we are talking about is due to the gravitational pull between them. So we can write the gravitational pull forces them to collapse. Now the next question says, describe and explain what happens as a protostar becomes a stable star. So when the protostar becomes a stable star, we will try to understand that first. As more and more matter starts coming into the clump, more and more heat energy is produced, and that leads to nuclear fusion reaction. When the nuclear fusion reaction is continued or it is going on, still at that time more mass is fusing into the clump that is already formed. Eventually what happens, the clump that is formed, it releases such intense heat radiations that for the remaining particles outside the protostar, it gets difficult to fuse into the protostar. At that stage, the further fusion of the particles, or you can say particles coming into the protostar, stops, and the protostar then becomes a stable star. So what can we write as pointers in this answer? We can say that the fusion reaction combines smaller nuclei and forms bigger nucleus. The gravitational force of particles is balanced by the force from radiations emitted by protostar. Okay, so as the further addition of the particles is stopped, the protostar then called as a stable star. That sums up our first paper. I would request you all to join our channel so that for all the further papers and the discussion of the papers, you will get regular updates. Thank you.